Good morning, everyone. Just a quick test to make sure everyone can hear.
Can hear you, Lance.
Perfect. Thanks, Dakota. How was your trip?
Oh, my trip was incredible. Thank you for asking. It was very good to be able to visit all of our affiliates overseas.
Good. All right, we'll be starting in about 3 minutes, everyone. Good morning, good afternoon, good night, wherever you may be. My name is Lance Isaac. I'm the Western Regional Sales Manager for HORIBA Industrial Process and Environmental. I'd like to welcome you all to the latest installment on our webinar series. Several weeks ago, we had our first webinar on our new Raman product, and today we will be following up with that with a refinery optimization webinar. Again, I would like to request that if you have any questions, please do log those questions in the chat, and once the presentation is finished, we will follow up by answering those questions. So without further ado, I'm going to give you just a very brief overview of what is going on here today. So there'll be introductions. Dr. Dakota Morales will be giving today's presentation a bit later on. Some of you may be familiar with him from our last webinar. I'll very briefly talk about who is HORIBA, what are some of the HORIBA products, and then we'll dive a bit deeper into the Process Raman. And as mentioned, we'll have a Q&A session at the end, which will be directed by Stevie Lee, our marketing manager. And after that, we will close. We are a hard stop at 1 hour today. If you do have any questions beyond that, again, please feel free to reach out. There will be contact information here in my next couple slides. So again, who is HORIBA? We are obviously a global company. We're based in Kyoto, Japan. We were initially started in January of 1953, and we're very proud to know that the HORIBA family is still operating the company. So it's a family business, only on a much larger scale. And we were incorporated here in the States in 1973. We have 3 different sites in North America. We have Irvine, California, which is where our admin and our financial folks are housed. We have Houston, Texas, which is where the bulk of our North American manufacturing is handled. All of our products, with the exception of maybe 1 or 2, are actually put together in our Houston office. All of our FATs, all of those types of things are all done in Houston. And then we have Salt Lake City, which is the headquarters for Process Instruments, which is our Raman group. So pretty good access as far as to where things are here in the States. Just a quick overview of some of our main products that we have here. We have ambient air monitors, the AP series. We have combustion control monitors, which would be the ENDA 7000. We have gas analyzers, which include our portable SIMs, the PG. We have trace gas analysis as well for ambient air monitoring. We do systems integration for products that are not only HORIBA products, but for our some of our competition. We've done integration of Siemens, we've done integration of ABB, we've done integration of Emerson. We are very well equipped to be able to handle any and all opportunities that are thrown our way. And then we also have field services. So whether you need any sort of demolition or installation, we offer those products as well. As you are familiar, HORIBA and process instrument, or HORIBA absorbed process instruments about a year ago in October. And with that, we were able to acquire the Raman analyzer. It's seen widely across industry as the gold standard when it comes to Raman. It is a multi-channel process analyzer. You can do multi-component per stream. You can do multiple streams. It is as many of you know, it is a fluid-based application, so it's a bit of a departure for our gas analyzer group, but it's something that we are definitely very, very excited about. We have several different options as far as how it can be presented, and is a fully customizable analyzer solution for your process. Here's a few of the applications. Again, as I mentioned today, we'll be focusing on refinery optimization, but again, here are just some of the basic overall applications that we have. Distillate monitoring, crude units, gasoline blending, alkylation. There are numerous different applications that we've already done, but we also are always excited about new opportunities. So if you have something that you think might work with a Raman, please feel free to reach out to us and we'll definitely explore that opportunity. Just a brief intro of who we are again here locally. Frank DeThomas is our fearless leader, our executive vice president and general manager. Brian Ross is our assistant general manager. We are very proud to welcome on Harsh Agrawal. He is our new product specialist that will be working with us on the gas analyzer system. We have Giancarlo Aguirre. He's our Salt Lake City / Process Instruments Operations Manager. Dr. Dakota Morales, who is the product specialist. He will be giving today's presentation. There's Mick Dolenmayer, who is my counterpart in the Eastern region of the United States. There's obviously myself. And then there's Samuel Francois, who's the regional manager for water products, as well as the Latin America coverage. So without further ado, one more reminder, we are available on all social media platforms. So we ask if you have any interest, please do go check us out on some of these, specifically YouTube. There are a number of videos and application notes and things of that nature that you can view online there. Please hit your like buttons on that so that we can gain some more support. And on top of that, if you have any suggestions about what you'd like to see in our next webinar series or in the future as far as what we may be able to offer, please reach out to us. You can do it on this format. You can send us emails. We're always happy to hear what our customers have to say. We don't want to assume we know everything. So we're always excited when someone comes to us with a suggestion, whether it be an application note or a webinar. We're always open to new opportunities. So without further ado, thank you very much. I'll be passing this over to Dr. Dakota Morales.
Hello, thank you, Lance. Good morning, everyone. Can someone confirm that my screen is showing okay?
Yes, you are on
Yes.
board.
Awesome. Thank you so much, Lance. Great. Okay, so good morning, afternoon, or night, everyone. Very happy to be able to do this webinar with everyone today on our refinery optimizations with HORIBA Process Raman. For Process Raman, refinery optimization is definitely our bread and butter. We have a bunch of experience with it, and we are very excited to be able to demonstrate that to our audience today. So thank you. Okay, so Process Raman, we are a part of HORIBA's industrial process and environmental segment. We are a part of a global network of different IP&E locations. As Lance went over, Process Raman headquarters is in Salt Lake City, Utah. And this is from the acquirement of Process Instruments in October of 2023. So with the acquisition of Process Instruments, HORIBA obtained over 25 years of Process Raman experience. Process Instruments was founded in 1994. Like I said, we have about over 25 years of Raman experience. We currently have implemented 165 online Process Raman installations worldwide. And then between all of those installations, we are currently have experience with over 450 different process streams, all with different applications, product tailorings, specific case-by-case basis. And that really is what gives us the very strong foundation that we have with our Process Raman analyzers. So just quickly going over what exactly is Process Raman. So we collect information on your refinery process by using Raman spectroscopy. So Raman spectroscopy is a light scattering technique where the idea is if we have a excitation light source like a laser in our analyzers, and we shine that on the molecules in your process stream non-invasively and non-destructively, a very, very, very large majority of the light source will be Rayleigh scattered, so there will not be an interaction with the molecule and the excitation light. But however, a very small portion of that excitation light will actually be Raman scattered. And this is, and will make the molecules present a unique spectral fingerprint from its Raman signal. And this is the sort of information that we use to collect for your refinery processes. As Lance said in the intro, we are definitely considered the gold standard for Process Raman analyzers in refineries, and that is because of our very high throughput, and which is extremely important for Raman scattering, since it is a very small percentage of the photons that are produced when molecules are excited with laser light, which we'll get into in a little bit. So some basic principles of Raman spectroscopy continued is these are the sort of vibrations that a molecule can sort of go through, but not all of them are Raman active. The most intense signal in our Raman spectra are produced from antisymmetric and symmetric stretching, as over here, whereas these sort of motions in our molecules are not so Raman active, or if they are very weak, or have sort of like a forbidden selection mode. Okay, so getting into online Process Raman, this is when we apply Raman spectroscopy to industry. So Process Raman is used in industries to monitor chemical processes in real time without needing to disrupt operations. And we design our Process Raman analyzers to be used 24/7, 365 days a year, because that's how your refinery operates. So for us to keep up with you guys, we need our analyzers to work as much as your refinery does. So we accomplish our real-time monitoring sort of through this general workflow with our online Process Raman. So In a very general sense, the first thing that we do when we work with an end user or a customer is decide the location of the sampling point for your process. So we either install a flow cell nearby the process pipe, or we install an immersion probe that goes directly into the process stream, as demonstrated here with this red arrow. And put that directly into your pipe, or flow the process into a flow cell where we can do our Raman spectroscopy there. Next, we then send a laser beam through the probe and flow cell so that we can generate scattered light, or the Raman light, as talked about a little bit ago. And from there, the Raman signal is collected by the analyzer to produce the Raman spectrum of the process. And then this is the good stuff. This is the information that allows us to decide the chemical composition of the process and gives you the sort of data that you are interested in to optimize and control your refinery process. So getting into the actual analyzer, the HORIBA Process Raman analyzer, we have the lowest detection limit for Process Raman on the market right now. We can go down to single-digit ppm, which is best in class for Process Raman, all the way up to, of course, total volume percents. Our analyzers work on fiber optic connections. So we don't bring sample into our analyzer, we just bring the light to your sample instead. And we do that through fiber optic connections, and that can be up to 350 meters away from our analyzer. We also allow for flow cell or direct insertion probes for sampling your process also. For sampling with Process Raman, we have no interference from water, particles, bubbles, or process temperature. These first three were covered in our first webinar, but just very briefly, we are insensitive to water, and through this webinar, we'll be going into why Raman is insensitive to process temperature changes and why that's not such a big deal for Process Raman. Also extremely important is that we do not require any sample conditioning. So there is absolutely no complicated sampling systems needed for our Process Raman. And also with our Process Raman analyzers, we can look at 1 to 17 different sample streams with just one analyzer. So that's extremely important for like large scale industrial applications like a refinery. Also with our chemometric models, it is very important to note that our modeling comes included with the analyzer. We offer full and holistic support for building and updating your models with your analyzer. We can look at multiple components per stream, various parameters, which we'll get into. And because of our state-of-the-art chemometric modeling and the very high throughput of our analyzers, we require much fewer samples to build our models than traditional methods like FTNIR or perhaps other Process Raman analyzers. And also the way that our lab analyzers are constructed and calibrated, we can transfer chemometric models from our laboratory analyzers to your process stream before the analyzer even shows up at your site for commissioning. So getting into the actual Process Raman analyzer, this sort of overview here, this is a picture of the analyzer and its general purpose rack on the left. We have the capability to monitor multiple components per process stream with minimal interference from water, temperature changes, gas bubbles, etc. All of our certifications down here allow us to be suitable for various hazardous and non-hazardous process environments, and we are compliant with ATEX Zone 0 and IEC EX standards here. Getting into the actual guts of the analyzer here, so this is just sort of a schematic illustration of how the analyzer kind of works with our fiber optic connections and our multiplexer, which allows for multiple sampling sites to be connected to just a single analyzer. So the multiplexer with fiber optic connections allows our analyzer to have the capability to switch between the sampling of multiple processes without any physical hardware changes or reconfigurations at all. So to sort of walk everyone through how our online analyzer collects, determines, and then reads signal and gives you the data that you want. We'll start with the computer that is located inside the rack. And the software in the computer controls the spectrograph, the fiber switch, and the multiplexer, so all of the different parts of the analyzer. And our online analyzers with the multiplexer all come with 2 redundant lasers. So the double laser feature allows for constant uptime of the excitation light source. So if the laser fails or experiences a sudden power drop, that's instead of shutting down your whole process or, not disallowing data to be collected, we can just run the backup laser immediately while the next laser is troubleshooted and or replaced. So the laser light goes into the fiber switch, and that fiber switcher controls which of the lasers brings the light into the multiplexer. And then from here is where the laser light can be sent to the first sample cell, the second sample cell, the third sample cell, etc. So the laser light is brought into the remote sampling point, which can be up to 350 meters away from our analyzer. Excites the molecules in your process. We collect the Raman signal back in the same fiber optic connection into the multiplexer here. This Raman excitation optic fiber is a relatively large diameter to allow for the very high signal to noise collection. And this Raman signal gets brought back through our lens, gets read onto our array, and then the image is created and read onto our camera. And then this is serially connected back into our software. And this is how the Raman spectra makes it to our computer, where our chemometric modeling determines the data and parameters and compositions of your process stream. So getting into the actual product line that we offer with HORIBA Process Raman. So we'll start over here on the left. This single and dual point process Raman instrument here is sort of what we like to call our flagship product. This is our most simple and most straightforward, versatile, and tangible solution for real-time process optimization and monitoring. So if you want to sample 1 or 2 process points, you would be interested in this analyzer. For more large-scale operations, or for our end users and customers who want to look at 3 to 17 sampling points with one of our online analyzers, we can interface a fiber multiplexer into your rack. And this is sort of designed for, really for scalability in mind, so that as your process Raman needs grow, we can very easily grow with you and be able to accommodate that. Our sampling options for our online analyzers, we offer flow cell enclosures that can be mounted on a wall or nearby your process stream. So we allow inline process analysis without disturbing your flow, perturbing your sample, etc. Down here is an image of our immersion probe, and this is the example of the probe that allows us for direct insertion into your process line. This right side of the table after the break is our laboratory analyzer offerings. So the first one here, this is our benchtop QC/QA laboratory analyzer. So this really excels at laboratory automation and very helpful for developing and validating chemometric modeling for your online analyzers. With our liquid auto sampler or LPG auto samplers. So our liquid auto samplers have a 42 vial set that can be used for laboratory automation, and our LPG auto sampler has 6 different bomb spots. So all of these laboratory equipment really not only can assist in your day-to-day laboratory needs, but they're really also used to support the online analyzers for building and validating the spectra and models for your process. So getting a little bit into more of the sampling points here. So This is a demonstration of our flow cell enclosure. So the idea is that we can bring your process stream and into your flow cell enclosure, and it will make its way into this flow cell right here in the screen box. And this image with the green shading is a cutaway of this green box here. So your process liquid, or your liquid of your process, will be brought up into here and do a turn. And at this turn in the flow cell enclosure is where we have a Raman probe that is situated against a window. And the probe brings the laser light into the process, and then we collect the Raman signal back into the probe. And then you can see the probe here, and this is fiber optically connected back into our analyzer. A very important and notable feature of our flow cell enclosure is our electronic grab sample detector. So when the end user or customer needs to collect a sample from the flow cell enclosure, the electronic grab sample detector can communicate back and provide a timestamp of when the grab sample was collected. This is some information on our immersion probe here. So our immersion probes are, we like to call them intrinsically safe, just like with our flow cells, because the only source of ignition in our immersion probe is the light itself, but the light is contained within the probe and is only shined onto your process through this window. So this can be installed directly in line into your process stream. So the probe is rated up to 210 bar or 3000 PSI. So this offers a solution to processes that require or that have a high pressure within them. The probe lengths can be customized from here, which is the area that is actually installed into the process stream. And our gland seal here ensures that no product or sample will ever leach into your immersion probe, or nothing should fall out into your process either. So just a way to protect us from you and you from us with our immersion probes here. Okay, so getting into the actual applications of our Process Raman with our analyzers. So today, we're gonna go over some of the like bread and butter stuff that HORIBA Process Raman has decades of experience with in petrochemical applications, so oil and gas refineries, chemical plants, and upstream solutions. So sort of giving an overview of our current customer base. This isn't everyone, but our customer base is highly loyal. The idea is that which analyzers really offer a return on investment to our customers. So when they invest in a Process Raman, they can get that ROI back through lower CapEx, lower OpEx, etc. And this is sort of what keeps our customer base happy and keeps them working with us. So the sort of refinery applications that we deal with here are listed here. Lance briefly went over this in the introduction, but we're going to get into this a little bit more right now. So some of the main refinery processes that we monitor are with distillation units in a refinery, different conversion and the chemical processes that happen in a refinery, like cracking, alkylation units, reforming units, etc. And also final product blending, so whether that be gasoline, diesel, jet fuel blending, different final product tailorings. Our Process Raman really shines in blending applications. So let's look at some of the common operational challenges in the petrochemical industry and how HORIBA solutions really address them. So on the left here, for all of our refinery engineers and chemists and managers that are in the audience right now, these are issues that many of your operations face, including off-spec product batches, which can lead to inconsistent product quality, unplanned downtime, which is always inopportune and mainly unpredictable, inefficient process control, which can be due to inadequate real-time data. And lastly, high maintenance costs with your OpEx because of frequent and timely maintenance requirements. But our Process Raman and HORIBA, we really offer targeted solutions for these challenges. So through real-time monitoring, we can enable immediate adjustments for your process, which helps maintain product quality and minimize off-spec batches. The early detection from our proactive diagnostics in our software and our analyzers reduces the chances of unplanned downtime. And of course, with optimized process control, operations become more efficient and your throughput will increase as you can produce more without compromising quality. And finally, our solutions offer reduced maintenance requirements by minimizing the wear and tear that happens to our equipment. And we completely remove the need for invasive or destructive sampling of your process. So really overall, we're just offering an approach that helps streamline operations, cut costs, and maintain your high standards of product quality. So let's get into some of the unique benefits of our HORIBA Process Raman Analyzer here. So really with our online Process Raman Analyzer, we can transform your refinery mindset. So our analyzer is designed to really streamline refinery operations by eliminating many of the traditional requirements and maintenance costs associated with other systems. So with our PI200 online Process Raman Analyzer, there's no need for chillers, recovery systems, or pump systems, making it much simpler and more cost-effective for your refinery. We also eliminate the hassle of column replacements like in process GCs, and we do not require any carrier gas installations or consumptions with our Process Raman, which reduces operational expenses even further. Also important, unlike many other analyzers, the PI200 remains unaffected by changes in your process. So if the temperature increases or something gets sent downstream that shouldn't, there's absolutely no physical impact on the HORIBA analyzer if your process changes. Additionally, there are very little moving part replacements. So there are fewer risks for wear and tear with our equipment. And additionally, our big one here, all calibrations are supported by HORIBA. So we're ensuring ongoing accuracy and reliability with us and with you. So if your winter blend, your summer blend changes, you need something updated, that's what we are here to help you with and support you. So this ultimately just, can be summarized by saying that this system, our system here, requires no regular maintenance, which significantly lowers downtime and operational disruptions. So our online Process Raman Analyzer really equips you with a solution that not only transforms your refinery mindset, but optimizes your refinery process as well. So getting into some of the actual specific applications here, in diesel fuel quality control for refineries, refineries traditionally use a variety of tools, like our engines here, cloud freeze analyzers, to get the data that they want. But however, these methods come with definite drawbacks. So for instance, the cetane engine here relies on temperature sensor that can drift over time, which requires frequent recalibrations to maintain accuracy of the readings. Similarly, like a physical property analyzer like cloud and freeze point, they require complex combustion measurements and often demands regular recalibrations as well. But here with HORIBA's Process Raman technology, we streamline this process by providing accurate and reliable in-time measurements for key diesel fuel properties like cloud points, flash points, your cetane numbers. And as you can see in this table over here, our Raman models align very, very well with the reproducibility and reliability with ASTM standards. So we offer very good reproducibility and repeatability value as well. Additionally, something that's very important that we really like to stress here is that our HORIBA Process Raman Analyzer can deliver these measurements in just 1 to 3 minutes, just very quick. So this minimizes downtime, eliminates the need for frequent recalibrations, which are associated with all of these traditional methods. And so this is really allows HORIBA Process Raman to be a very efficient and also dependable solution for your inline diesel fuel quality requirements. So here on the left is a Raman spectrum of blender diesel here, and then a calibration curve for a cetane index here. And some more benefits that we offer with our Process Raman for something like diesel fuel here, right, is you can, for optimal, we can keep aromatic contents within your specs, so no more off-spec blending. We keep sulfur, we can help keep sulfur within a 15 ppm limit with our low detection limit, so we can model that out. We also, some parameters like detecting components that lower the flash point of your blends. And we can, our Process Raman can help match cloud and freeze point temperature targets for colder climates, which is very important for diesel fuel blending. So for gasoline fuel quality control, traditional methods typically involve using a CFR engine to determine octane rating. But you know, a major drawback here is that these engines can experience buildup and definitely wear over time, which leads to inconsistent knock readings, and then that requires regular maintenance. And also the CapEx for something like this is also very expensive and costly. And we also, of course, have the RVP analyzer to measure volatility, but it very often suffers from sensor drift and clogging, which impacts accuracy and demands frequent recalibrations. But our Process Raman Analyzer simplifies and improves this process. So with our Raman models, we can measure key gasoline properties such as RON, MOD, MON, and RVP all in line and all within the same reading and chemometric model. So we can provide rapid and accurate results without frequent maintenance that these traditional methods require. And as shown in this table once more, our Raman Analyzer offers very close reproducibility and repeatability values for these important measurements. So we completely align with all refinery industry standards as well. Likewise, our very quick measurement times of just 1 to 3 minutes. The Process Raman Analyzer here really allows for continuous monitoring, reducing downtimes, and ensuring consistent fuel quality with our very quick typical measurement times for our gasoline blending applications. So here on the left is a spectrum of a Raman spectrum, I should say, of blender gasoline with a calibration curve of neat to MON with the measured and predicted values plotted against each other. So with our Process Raman, you can predict key product properties of your gasoline fuel, such as octane, RVP, obtain distillation temperatures, all that good stuff, as well as, of course, predicting of regulatory properties such as aromatics like benzene and different olefins. And depending on where component feeds to your blender, and then monitor blender products after with and without additives, so NEAT and MTBE as well. And then also, of course, monitor final tanks in refineries. So this is just sort of, you know, trying to demonstrate the real power that we have when it comes to these blending applications with HORIBA Process Raman. Something else that should not go unnoted for sure is that HORIBA Process Raman is insensitive to your process temperature changes. So over here on the left is this big data table of a bunch of gasoline parameters that we can measure in just one chemometric model with different parameters listed here in the rows. And these 3 columns here are the measurements taken of this gasoline sample at 0 degrees Celsius, 23 degrees Celsius, and 48 degrees Celsius. And you can see across each parameter here, you get very virtually the same result every single time across this wide temperature range. So these stable and reliable results across the temperature changes are very important for becoming, for allowing your process temperature changes to not affect your chemometric modeling or the results that you want. Likewise, because we are temperature insensitive, we require less samples, whereas in FTNIR or other traditional analyzers, the temperature must remain constant through a sampling system, and in case the sampling system drifts or moves a little bit, the chemometric modeling for those analyzers should also pick up on temperature changes, and those have to be modeled out. So we don't have to worry about any of that at all. So this just leads to less calibrations and less samples needed for our customers. And just restating once more that there's no physical impact to your HORIBA analyzer if process temperature changes. So another key unit of a refinery here, the reforming unit. In refinery reforming units, effective monitoring of feed and product properties is extremely essential, right, to maintain quality and optimize production here. So here on the left is a process Raman spectrum of reformate here with a calibration curve for the RON values. So with Process Raman, we offer significant benefits for reforming units in refineries. So HORIBA Process Raman can very quickly predict key feed properties, such as your classic piona, your N-hexane and heptane cycle. And then on the after side of this, product properties, we can monitor I-hexane, methyl cyclohexane, benzene, just as it's being demonstrated in this calibration curve. We can monitor reaction processes by predicting octane numbers, octane components, and RVP as well. And also monitor undesirable cracking reactions that form butanes and lighter gases by monitoring these concentrations. And then, of course, another important application is that we can monitor BTX feedstock production. BTX components have some of the strongest Raman scattering of the hydrocarbons that we look at. So this is another very excellent opportunity for Process Raman as well. In our reforming units, typical measurement times that we work with our end users and customers is roughly every 2 minutes. So very efficient and productive use of Process Raman here in this refinery application. Okay, here we can start getting into some of the benefits of our Process Raman technology in the alkylation unit in a refinery. So this slide is really highlighting 2 different main aspects here. So over here is the Process Raman spectrum of a strong acid catalyst. This is sulfuric acid here. So in an alkylation unit, right, operating variables are key for the efficiency and productivity of an alkylation unit. So things like acid strength, reaction temperatures, monitoring isobutane to olefin ratios are all very critical for alkylation units. And so on the right here, we have a table showing some modeling results for various olefin inputs, and also including parameters like propane, propylene, isobutane, etc. And all of our parameters here have a very high R² value. So this is just again showing our very strong predictive accuracy in our state-of-the-art Raman models that our factory can help build and update with your refinery team. So these sort of insights enable very precise control of olefin feed composition, improving process stability, improving product yield, etc. Over here on the left is a process Raman spectrum of alkylate that we typically can model here in this calibration curve. This calibration curve is showing ethane concentration. So we can predict key olefins to optimize alkylation feeds, predict key properties such as octane right as shown to optimize alkylation products. And then we can, of course, monitor recycled HF or sulfuric acid concentrations. And then, of course, at the end, monitor various fractionation stages. And again, typical measurement times very quick of about 2 minutes with our process Raman. Another important unit and process that refineries include in their day-to-day operations is their cracking units. So going through this block diagram of this FCC unit here, these red stars that have P are our HORIBA process Raman measurement points. So typically, these are where our end users like to install our process Raman to monitor feedstocks into the cracking unit, and then of course the different fractions that are produced from the FCC unit. Here on the right is a MCP calibration curve of the weight percents, the measured versus the predicted. And as you can see here, from our results, our calibration accuracy shows a residual error of 0.03 total volume percent, which is very, very low. And just further demonstrating the lower detection limits and real performance that our process Raman can be employed at. Some more Raman benefits here for our FCC units that our end users really enjoy having is monitoring key feed properties into the FCC unit, monitoring the fractionator cuts as it leaves, of course, monitoring PIONA of light and heavy naphtha splits. We predict octane loss for post-FCC naphtha hydrotreating, which we'll get into in a second here. And then also monitoring cut points for the naphtha and the LGO cut points for changing petro market needs. So this is, we'll get into this in a second also, but typical measurement times here are about 2 minutes also for our FCC units. So very quick, very efficient. Okay. Whoops. Sorry about that. Okay, so I'm so sorry about that. My PowerPoint froze for a second. Thank you. So for our FCC hydrotreater application, so our FCC stream, we can monitor HORIBA process Raman here. After the separator, as it's split into its light and heavy cuts, as it goes through our hydrotreater, and then after the hydrotreater, and then of course after it's diluted and mixed before it goes into its blend header here. So some HORIBA process Raman benefits that we offer is here you can measure the quality of feedstocks before and after hydrotreating. You can also optimize the improvement of the quality of your feedstocks by monitoring what's coming in and out. You can also use process Raman to measure contaminants like sulfur to very low ppms as well. And typical measurement times for our feedstocks monitoring, of course, is about 2 minutes in this example here. Likewise, I promised that we would get into some of the distillation monitoring that we can help our end users monitor and work with here. So we can measure the composition of crude oil in real time. So this allows us to optimize and maximize output of your crude oil characterization. So this is a case example that we've worked with an end user before, where we were able to optimize the cloud point window, optimize the 90% cut point, and optimize the flash point of their heavy naphtha into their diesel product. So all of these things were accomplished with our HORIBA process Raman chemometric modeling and real-time monitoring that our analyzers afforded our end user. And so because of the changing markets, they are able to now blend more heavy naphtha into diesel product when they want to produce less vacuum oil products, depending on their refineries' needs. So as described a little bit earlier, through all of our refinery applications, everything that we've gone over before, all of the benefits that our analyzers and chemometric modeling provide, a big main benefit here is a return on investment for our end users and customers. So as a online analyzer is first installed into a refinery, that allows for real-time data to be collected, modeled, and monitored, which ultimately drives optimization of refinery processes. And then that, with our performance channels and our predictive maintenance, reduces downtime and maintenance cost for the refinery, which just allows it to operate more efficiently and more, productively. So enhancing product quality and yield is sort of the next ramification from that. And then all of these combined lead to increased profitability for our end users and customers. So the main point of our Process Raman for a lot of our end users is all of these things can be combined to use our analyzers to make your refinery more money through enhancing product quality and yield, reducing downtime, et cetera. And then that can be used, again, the ROI can be used for additional process streams, additional analyzers, new applications as they're developed, et cetera. So that's sort of, the cycle that our short and long-term customers see with their return on investment with HORIBA Process Raman. So to quickly just sort of wrap up here, going over some of our key advantages for HORIBA Process Raman. We offer direct Raman measurements of your process. We can achieve 1 to 17 different sampling points with just one Raman analyzer. Our detection range is the best in class for online Process Raman. We can get down to single-digit ppm to whole 100 volume percents. And of course, if your refinery application, for example, if you're sitting here thinking like, oh, I wouldn't need single-digit ppm, this is also can be related to the speed of the analysis that our HORIBA Process Raman offers. So in the same amount of time that it would take a competitor to measure a low volume percent, we can do that at a much, much, much faster rate because of our very high throughput of our analyzers. Likewise, our redundant backup lasers and the automatic switching that is provided in the software assures maximum uptime for your online Process Raman needs. Because again, we understand your refinery works 24/7 all day, every year, and so do our instruments. We also offer state-of-the-art chemometric modeling support that comes included with the analyzer. So we will work with your team to build models before your online analyzer even shows up to your site. And then of course, from there, updating models, building new models for other applications, et cetera. Our factory and our company is very happy and proud to support that for our end users. And it comes included for the first year with the purchase of our analyzers. Our installation can be commissioned, usually takes about 2 days to get everything up and running, and then plus about a day of on-site training. But of course, we won't leave until you guys want us to leave. So any additional training, our team is also very happy to engineer and coordinate with you guys as well. And this is the real statistic for our typical maintenance. It's about 2 hours per stream per year. This is low because of the way that we don't require sampling systems. We don't need chillers, pump systems, recovery units, column maintenance like in a GC, et cetera. So, and in any case, if there is downtime, everything is entirely backed by our team of experts and technical support here at HORIBA. Okay, so thank you very much for watching our webinar here. So stay tuned to our webinar series on Process Raman. The whole point of these webinar series, right, is to keep our audiences and our end users up to date on our Process Raman. So any new products that we have, more application overviews like this refinery one, we are excited to be able to share that with everyone. Also, please feel free to contact us about anything, comments, questions. We can set up another meeting. Just like Lance said, if I went over something or if I didn't go over something that you might be interested in an application, we will be very happy to evaluate that with you and your team and get that figured out. So please feel free to contact us with any questions or comments or future evaluations. So once more, thank you all very, very much for attending our webinar today and for your attention. So yeah, thank you.
Thank you
And if
very
anyone
much.
has, yeah, I'm sorry, Lance, go ahead.
Stevie, we'll call on you right now to, I can't see whether or not there are any questions in the chat, but if there are, let's go ahead and open that.
Yes, we do. Thank you so much, Dakota. It's very informative. We do have a few questions we would like to ask you from the audience.
Okay,
The
great.
first question is, I guess two people asked the same question, is how powerful is the laser that we're offering? And is it institutional or extractive?
Can you say the first part of the question again, Stevie? I'm sorry.
Yes, how powerful is our laser that we offer?
So our laser operates at 450 milliwatts, typically, is the power that we run it at. The typical wavelength of our laser is a single mode 785 nanometer laser. And the first laser comes through, or sorry, I should say that the lasers come with the purchase of the analyzers, and backup lasers can be purchased and at the probe tip. So the actual laser power that is leaving the Raman probe is 450 milliwatts.
All right, thank you. And is it the laser we offer, is it institutional or extractive?
I'm not sure what is meant by extractive. We build our lasers in-house. So we build and align and calibrate and test all of our lasers here in Salt Lake City, if that's the question. I'm sorry for it is in situ,
no.
if that's the question.
All right. So the next question is why moisture and dust won't interfere with the measurement, and how much is the max that we can offer to measure moisture and dust?
Yeah, so if the lab analyzer is going to be located in a very humid area or out in the field, I didn't get into it in this webinar, but in the first webinar that is also on our YouTube channel and other social media platforms, we went into the sort of purged enclosures that are different zone certified that should be able to circumvent or abate those things.
All right. So the next question is which all component can be measured with Raman analyzer?
Which sort of components can I follow up with?
I guess the question is how many components can we measure by using our system?
Okay. Yeah, so as many as so for example, in a typical LPG stream or like in those gasoline model data table that I was showing before, we can measure up to several different parameters at once. That can be distillation temperatures, that can be octane numbers, that can be individual components and concentrations of those components, all within the same collection and model that can be applied to that Raman spectrum. So it's a multi-component analyzer per process stream.
All right. And the audience just wondering, is it, do we offer different laser for different measurement?
Yes, our lasers, so a short term, and there will be a webinar on this eventually as well, so stay tuned. But we are currently developing a longer wavelength laser that will be able to handle darker samples like lubrication oils or also really get into amine degradation, things like that. So we are able to extend our laser wavelength options as well.
All right. And the audience wondering if our laser module is explosion proof or not.
Yes, everything. So we are certified for hazardous and non-hazardous installations. We are ATEX Zone 0 certified as well.
All right. So what is the price range for our Raman system?
So it really is usually on a case-by-case basis. We really like to work with our end users on developing exactly what they need so that we can give the most accurate price points and the most up-to-date sort of pricing that we offer our end users. So if and it varies depending on if the analyzer is a single point analyzer or if there's a multiplexer involved. So I asked the user that asked about the price range. Please feel free to contact us with your information, and then we can start an evaluation and give you more of an accurate ballpark for your needs.
All right, thank you.
Absolutely. I would for sure like to second that. There's a significant amount of variables involved with us putting together a quotation, and we want to make sure that we have all those parameters covered. So as Dakota said, it is very much so a case-by-case basis. So if you do have questions and if you would like us to explore that option, please do reach out to us directly, and we'll make sure that we can start down that path.
Thank you, Slam. The next question is, what is our positioning in CapEx compared to the Raman solution in the market, especially the one made in for the EU region or from the EU region?
So we are worldwide. Our main customer base is certainly in refineries in America, but in any case, when it comes to validating the instruments or obtaining certifications for installations in the EU and things like that, our systems are completely amendable and able to be installed regardless of the actual region that the analyzer will go into. And this is also something that we can work with on a case-by-case basis too, because we also know from our experience that different regions or countries, of course, require different certifications for lasers or whatever it might be. So we understand that, and we're happy to accomplish all of that with you.
All right. So what is the maximum and minimum budget required for our customer? Do we offer that wide range of budgeting?
Yeah, I think that is also would be best answered for the on a case-by-case basis for the different applications, right? Because a single point analyzer where we're just looking at one sample with something like that would be would be on a completely different sort of budget range than a analyzer with 17 sampling points, you know what I mean, and all the support that goes into that. So our single point analyzer would be a lot more in line with what you might expect typically for a Process Raman analyzer. So that is our most price competitive option. But again, without getting into too many specifics, it really is like a case-by-case basis. So please reach out to us directly, myself, Lance, or John Carlo, our operations manager, and we will be very happy to give you undivided attention so that we can get that budget for you.
All right, we still have quite a few questions, but we run out of time. So we would like to follow up with everyone for your questions if we didn't have a chance to answer your question today. And again, you have the contact from Dakota and Lance and the rest of our team. And we look forward to hosting another webinar to answer for the question if we didn't have a chance to answer today. And from my end, I would like to remind everyone that we will have a survey coming out after this webinar, so you can have a chance to ask more questions or give us some feedback regarding the 2 webinar series that we having so far. And you can catch this one recorded on our YouTube channel in a few days after this webinar.
Thank you very much,
Thank you so
Phoebe.
much, everyone.
Yes, thank you.
Absolutely. Thank you very much, everyone. Again, if you have any comments, if you have any questions, if you need pricing information, please do reach out to us directly and we will be sure to follow up. If you have any recommendations for future webinar series topics, please do forward those as well. Thank you, everyone. Have a good evening, have a good afternoon, and have a great day. Thank you for your time.